Hey guys, we shall continue with the transform analysis of LTI system. So we have a system in terms of difference equation. Our aim is to find its system function h of z and its impulse response h of n. So in the previous problem, they used to give us input x of n and output y of n, and they used to ask us to find system function. Here we don't have in terms of input output, but it is actually in terms of difference equation. Okay, so how do we solve this if it is in terms of a difference equation? So we'll try to solve it. So it's easy actually. What we do, we separate all the input part and output part. Output part we write it in the left hand side, and the input part we write it in the right hand side. Okay, so y of n minus 1 by 4 into y of n minus 1 minus 3 by 8 into y of n minus 2. So this is our output part is equal to, if this goes to the right hand side, minus of x of n plus of 2 times x of n minus 1, right? Now what I do, I'll take z transform on both sides. Take z transform on both sides. So what do I get? What is the z transform of y of n? Y of z minus, what is the z transform of 1 by 4 into y of n minus 1? It is nothing but y of z into z power minus 1, time shift property, right? Z transform of x of n minus n naught is what? X of z into z power minus n naught. So if n naught is 1, the transform of x of n minus 1 is nothing but x of z into z power minus 1. That's what I did. The transform of y of n minus 1 is y of z into z power minus 1. So minus 3 by 8 into what? Y of z into z power minus 2. Again time shift property. Here it is 1, here it is 2. So this is equal to minus of the transform of x of n is x of z plus 2 into x of z into z power minus 1. Again time shift property. So now what I do, I'll take y of z common. Y of z 1 minus 1 by 4 z power minus 1 minus 3 by 8 z power minus 2. In the right hand side I take x of z common. So if I take x of z common, what do I end up? Minus 1 plus 2 into z power minus 1. Right? Okay. Now I'll bring this in the form of y of z by x of z. I have y of z here. X of z I'll take to the left hand side, and this I'll take it to the right hand side. So y of z by x of z, right? And what is y of z by x of z? This is nothing but our system function h of z is equal to, it is minus 1 plus 2 z power minus 1 divided by 1 minus 1 by 4 z power minus 1 minus 3 by 8 z power minus 2. Since these are in negative power, I need to convert it to positive power. So what I have to multiply? Z square, y square, because highest degree in the negative side is minus 2, right? So what is the next step? So next step is to bring it in the form of h of z by z form, right? So we have h of z. Before that, when I convert it to positive power, it is minus z square plus 2z divided by z square minus 1 by 4z minus 3 by 8, right? Yes, 3 by 8. So now I'll bring it in the form of h of z by z, which is equal to minus z plus 2 divided by, I factorize it, I get pole at z is equal to 3 by 4 and one more pole at z is equal to minus 1 by 2. Just check this poles. Once I get this, I have to perform the partial fraction expansion, which is a divided by z minus 3 by 4 plus b divided by z plus 1 by 2. So where a, you know the formula, right? We get 1, and b, I'm not solving this with formula, I'll try to write the values, b is minus 2. So therefore what do we get? H of z by z is equal to 1 divided by z minus 3 by 4 plus minus 2 divided by z plus 1 by 2. So if I take this z to the other side, so I get h of z as z divided by z minus 3 by 4 minus 2 into z divided by z plus 1 by 2. So what is the next step? I have to take its inverse z transform on both sides. So what is the inverse z transform of h of n? It is h of z. It is equal to, it is 3 by 4 power n u of n minus 2 into, since I have plus, I have to write minus 1 by 2 power n u of n. So this is the impulse response of the system. So what else I need to find? I need to find impulse response and system function. And where is our system function? System function is this. This is our system function.